In our last couple of examples for solving trigonometric equations, we're going to see a coefficient in front of the variable inside of the trigonometric function. So as you can see right here, we have a 2 that's in front of the x. So we're going to have to deal with that after we have isolated the trig piece, after we have taken the arc cosine of both sides, and after we've applied the definition of the arc cosine. So it's essentially going to be the very last thing that we have to deal with. So to get us started, we do have to isolate the trig piece. So I'm going to divide both sides by 2. So we've got cosine of 2x equals negative root 3 over 2. So at this point here, we can now take the arc cosine of both sides. So that means that'll cancel out with the cosine over here on the left. So we'll get 2x equals the arc cosine of negative root 3 over 2. So at this point we can take the definition of arc cosine. So we've got 2x equals plus or minus the inverse cosine of negative root 3 over 2 plus 2 pi n. So all of this is just like we've done before. So I'm going to find what the inverse cosine of negative root 3 over 2 is. So I've got 2x equals plus or minus. So I go to my unit circle, and I know that the angle that has negative root 3 over 2 as the x-coordinate is 5 pi over 6 plus 2 pi n. And so now at this point, the last thing I need to do is deal with that 2 that is in front of the x. And so we've just got to divide both sides of our equation by 2, or it might be a little bit easier for us, since we've got that fraction of 5 pi over 6 that's going to be affected by this, to multiply both sides of the equation by 1/2. And we do have to recognize that everything is going to get multiplied by that 1/2. So we end up with x equals plus or minus, and so 1/2 times 5 pi over 6 is 5 pi over 12 plus, and then of course we have to distribute that 1/2, so it multiplies that 2 pi n, so we have plus pi n. And so this is our infinite solution set. And so then if we want to list off our answers that are over that 0 to 2 pi interval, we need to start plugging in our integer values for n. Before we do that, it's probably useful for us to split this up into negative 5 pi over 12 plus pi n, whoops, that's an n there, and positive 5 pi over 12 plus pi n, and start plugging in our integer values. So if we plug in 0 for n, clearly the one on the left there is going to give us a negative value, but we're going to get 5 pi over 12 out of the one on the right. If we plug in now 1 for n into each of these, so if we plug in 1 for n on the left there, we get pi plus 5 pi over 12, negative 5 pi over 12. So negative 5 pi over 12 plus 12 pi over 12 gives us 7 pi over 12. For the other side there, 5 pi over 12 plus pi means 5 pi over 12 plus 12 pi over 12, so 17 pi over 12. So that is still in that 0 to 2 pi interval. And then we can go ahead and plug in 2 for n into each of these. Well, clearly the one on the right, that's going to be too big. If I add a positive number to 2 pi, that's going to be bigger than 2 pi. But if I add negative 5 pi over 12 plus 2 pi, or negative 5 pi over 12 plus 24 pi over 12, I'm going to get 19 pi over 12. So there's our set of 4 angles, 4 values for x that are between 0 and 2 pi. In this last example, so with the 1/2 in front of the x inside of the parentheses there, so we're going to have to deal with that last. So we'll first isolate the tangent piece by adding 4 to both sides, and then we can divide by 4 as well. So we're ultimately going to end up with tangent of 1/2 x equals 1. So we can take the arctangent of both sides. So the arctangent of the tangent of 1/2 x leaves us with just 1/2 x equals the arctangent of 1. So now we can apply our definition of arctangent. So we have 1/2 x equals the inverse tangent of 1 plus pi n. And so now we have to find what that inverse tangent of 1 is. So I think we've seen that in a previous example. So we're going to get pi over 4. So for an answer that's between negative pi over 2 and positive pi over 2, for the inverse tangent of 1, we're going to get pi over 4 plus pi n. And so then our last step is to get rid of that 1/2 that's in front of the x. So I'm going to multiply both sides of my equation by 2. So that means I have to multiply everything by 2. So we get x equals, so 2 times pi over 4 is going to be pi over 2 plus 2 pi n. So there is our infinite solution set. And so then for our answer that is over that 0 to 2 pi interval, I'm going to take I'm going to take n and replace it with 0 to start off with. So I get pi over 2 as the first of my answers. And then if I try plugging in 1 for n, I can see that I'm going to have pi over 2 plus 2 pi. That's going to be bigger than 2 pi. So this time we only have one answer that falls in that interval. It's pi over 2. So that's our only result that falls over the course of that interval.